Hey space enthusiasts, welcome back to our channel. Today we've got some thrilling news about an innovative company making waves in the aerospace industry, Stoke Space. They've just test-fired a highly efficient engine for their fully reusable launch vehicle. Let's dive into the exciting details. On June 5th, Stoke Space conducted a brief but groundbreaking test of their new engine at a test site in Moses Lake, Washington. This engine, designed to produce up to 100,000 pounds force of thrust, achieved 50% of its rated thrust in this initial 2-second test. The main goal was to assess the engine's startup and shutdown processes, which are critical for overall performance. Stoke Space's CEO, Andy Lapsa, highlighted the importance of this test. He said, "All of the complexity and a lot of the risk is in that startup transient and shutdown transient." This means that while the test was short, it was crucial to understanding the engine's behavior under these conditions. The engine uses a full-flow staged combustion design, where both the fuel and oxidizer go through separate preburners before entering the main combustion chamber. This design offers greater efficiency and longer engine life, but is more complex to develop. Currently, this approach is only used by SpaceX's Raptor engines. Lapsa explained that they chose this design because it's essential for rapidly reusable launch vehicles. He said, "In a world of rapid reuse, you need high performance. Full-flow stage combustion gives you the highest performance possible under the least stressing conditions." Right now, the testing is focused on the startup and shutdown phases. Stoke Space is building a larger test stand set to be completed later this summer, to enable longer duration tests and a full qualification test campaign. Stoke plans to use 7 of these engines on the first stage of their fully reusable medium-lift launch vehicle, Nova. The upper stage, however, uses a different technology with liquid oxygen and liquid hydrogen integrated into an actively cooled heat shield for powered landing. They tested this system with a prototype flight last September. Despite the different technologies, there are some commonalities between the booster and upper stage engines, particularly in the turbo machinery and analysis tools. However, they are largely distinct systems. Stoke is progressing on other aspects of the vehicle as well. The recent engine tests used flight avionics and software, and the company is refining the design of the upper stage. This work is funded by a $100 million Series B round raised last October. Lapsa expressed confidence in their progress, saying, "In a lot of ways, all systems are go, and the last big question mark that I felt carrying on my shoulders was the first stage engine, and specifically getting the engine through the transients and back successfully." Stoke aims to begin orbital flight tests in 2025, with hopes to accelerate the schedule. However, the timeline depends on when they can start work on their launch site at Cape Canaveral's Launch Complex 14, allocated by the Space Force last year. This test took place just 18 months after the company began designing the engine. Lapsa believes that fully rapidly reusable rockets will eventually render all others obsolete, and high-performing engines are key to this future. He said, "I think it's an essential technology mountain to climb, and I'm really excited to be on that mountain."